procedure where we will be able to find orthonormal basis functions. Okay, then after that we have also started one more topic, conversion of continuous AWGN channel into a vector channel. Okay, vector channel. Okay, so this is what the topic I've just started also, and I've given you explanation as well. Okay, and but still I have little more to teach in this, so let me just brief you again. Okay, so here what is happening, as you know, for each mi bit you'll have the SA of t, which is nothing but the modulated signal. Okay, so if you just recall the diagram, you'll have the message source, then you'll have the vector transmitter. Okay, message source, vector transmitter, and then after that you'll have the modulator, and modulator will also take the carrier signal. Okay, then the output of this, here the input will be mi, here it will be si, and the output of modulator is nothing but SA of t. Okay, then what this entire thing is nothing but at the transmitter side. Okay, so for each mi there will be one SA of t. Okay, for m1 there will be S1 of t, for m2 there will be S2 of t, like that, so on. Okay, until we are assuming that the number of symbols that it will generate will be from 1 to m symbols. Okay, so for it will be Sm of t. Okay, so now what we'll do, I will just give it to the channel. Okay, here this is my channel. Okay, channel, and from the channel it will be received at the receiver end. Okay, the receiver will receive the signal. Okay, the receiver will have the detector and also decision making device or vector decoder. Okay, vector decoder. Okay, so what happens here, S of t. Okay, whatever S of t I am transmitting it through the channel, the receiver has to receive that SA of t. Okay, so generally SA of t, as you know, we will represent SA of t using the orthonormal basis functions, which is denoted as SI1 phi1 of t plus SI2 phi 2 of t, so on, SIM phi n of t. Okay, SIN phi n of t. Okay, so this is how SA of t will be generated here. SA of t will be generated. This is, it will be transmitted to the SA of t, to the receiver. Okay, so I have also shown you how to represent this SA of t when you have SI1, SI2, SIN. Okay, so for that you will have the product modulator where you will give SI1, and phi1 of t will be the orthonormal basis function, so that you'll get here as SI1 into phi1 of t, that you give it to the summer, like that. You'll have SI2 that will get multiplied with phi2 of t, and then that will be given to the summer. Okay, and then finally so on, like that you will have SIN that will get multiplied with phi n of t. Okay, and that will be given to the summer, so everything will get added, so that I'll get SA of t. This is all is happening at the transmitter end. Okay, and receiver end, so what the receiver has to do, it has to detect this SA of t and convert. Reverse process should happen here. What is happening, from mi SI is generated, from SI SA of t is generated. At the receiver, ulta operation should happen. SA of t it has to take, SI it has to generate, from SI it need to estimate m cap. Okay, so SI, I need to get SI. Okay, SI, or I can write as SI is nothing but SI1, SI2, so on, SIN, right? So I need to get SI1, SI2, SIN. Okay, so in order to get that, the equation to calculate the same is Sij is equal to, one second. I'm sorry, I just had some disturbance. Okay, fine. So Sij can be found, Sij, because I need Si is nothing but Si1, Si2, Sin vector, right? So in order to get Sij, I need to take integral 0 to t Si of t into phi j of t dt. This is how I'll be able to get Sij. Okay, so what should be there? I should have the Si of t, so that in order to get Si1, first Si1, I'll just multiply Si of t with phi 1 of t, so that I'll get here Si of t into phi 1 of t. When I give it to the integrator, then only I'll get Si1. Okay, next, in order to get Si2, I need to give it to the product modulator. Then I'll get Si of t into phi 2 of t. Again, after integration from 0 to t dt, I'll get as Si2. In the same way, I have to just take it n times, so that phi n of t, multiply Si of t with phi n of t, so that the output here will be Si of t into phi n of t, and give it to the product module integrator, so that I'll get Sin. Okay, so this is how the vector is generated. But when you observe, the Si of t, where is it? The Si of t is passed through the channel. Okay, ideally this is how the receiver, this is nothing but the receiver circuit. This is at the receiver or analyzer, analyzer. Okay, so ideally it should happen in this way. But what is happening at the after Si of t is transmitted through the channel will have some additional noise. Okay, so here I'm just adding white Gaussian noise, additive white Gaussian noise. So whatever I'm receiving here, it is not just Si of t, the W of t will also get added to this. So the overall signal, I'm calling it as X of t. Okay, so this is what is happening ideally. So whatever I'm adding here, it is nothing but additive white Gaussian noise. Okay, so conversion of continuous additive white Gaussian noise channel into a vector channel. So so here what is happening, the receiver is receiving X of t instead of Si of t. Okay, this X of t should be converted to Xj. Okay, so that is what I need to find here. Okay, instead of Si, I need to find Xj. Okay, Xj. Okay, Si was the thing what I need to get here, but instead of Xi, I'll get Xj. That is only the difference. Okay, so here I'll just do some analysis. So channel will add additive white Gaussian noise. I've already explained you what is additive white Gaussian noise. Okay, so additive, we call it as additive because it is getting added to the signal Si of t. That is the reason continuously it is getting added with the Si of t signal. That is the reason it is said to be additive, and it is said to be white because the power spectral density, Sx of f, Sx of f. Okay, Sx of f will be constant throughout. Okay, for every frequency, the power spectral density will be same, and it will be N0 by 2. That is the reason it is said to be white Gaussian noise. And for the complete frequency spectrum, the amplitude will remain same, and it is N0 by 2. Power spectral density of white Gaussian noise will be N0 by 2. And why it is said to be the Gaussian noise? Because the probability density function, PDF, small PDF. Okay, so hope you people know what is probability density function. Anyway, I'll just explain you again. So its characteristics will be in this way. Okay, the PDF of the Gaussian noise will be in this way. Okay, so it indicates that the mu is nothing but the mean will be equal to 0 here. Okay, mean of Gaussian noise will be equal to 0 here. Additive white Gaussian noise, the mean will be equal to 0, and the power spectral density will be equal to N0 by 2. Okay, so coming to PDF, I think you all know what is probability. Okay, so if you take the dice, okay, so dice will have 6 numbers. Okay, so let me consider that I need to get addition like what all combinations I'll get. If I'm tossing 2 dice, okay, or if I'm throwing 2 dice, then the combinations are 1,1, 1,2, like that so many combinations I'll have, right? So how that combinations are distributed, that is said to be the probability distribution function, PDF, okay, which is denoted as capital F of X. Okay, the derivation or the difference, okay, let me consider I have something like this, some run like 1 second, some statistics like this I have, let me consider. Okay, so now what I'll do, yeah, to find the small PDF, this is probability distribution function, probability distribution function. Okay, whereas probability density function will give the difference between these events that are occurring, or the probabilities. Okay, probabilities of the events that are occurring, that is said to be your PDF. Okay, it is denoted as small f of x. Okay, so that is what the PDF. So for the additive white Gaussian noise, the Gaussian distribution function will be the normal distribution function. This is said to be the normal distribution function with mean is equal to 0. Okay, so that is the reason this is said to be additive white Gaussian noise. Okay, I'm just explaining you what is additive white Gaussian noise. Okay, so the main things what you need to understand here is additive means it is getting added to the signal Si of t. That is the reason continuously it is getting added, so it is said to be additive. And white because its power spectral density is n0 by 2, and Gaussian noise because it is taking the normal distribution like this. Okay, with mean is equal to 0. Okay, so the this additive white Gaussian noise is getting added with the, okay, let it be, it's getting added with the SA of t signal. So how will be what will happen at the receiver? The receiver will not receive SA of t. Instead, the SA of t will get added with the additive white Gaussian noise W of t. Okay, it will get added with additive white Gaussian noise. Both will get added, and I'll get x of t. This x of t will be given to the correlators. Okay, generally the product product multipliers and the integrators. Okay, product plus integrators are said to be the correlators. Okay, so correlators. Okay, these are said to be the correlators. Okay, since we have correlators, what will happen? This x of t will be given to the correlator. Okay, correlator in the sense you will have a product multiplier which will multiply x of t with phi j of t. Okay, or if you want me to draw like this also, I can draw. Okay, first let me draw in this way and then I'll expand it. So pi j of t, which will be given to integral 0 to t dt. Okay, so this entire thing is nothing but the correlator. Okay, correlator, so that I'll get xj here. Okay, not si. I need to get si. Instead of si, I'm going to get xj here. Okay, so that is what here. This is what is happening at the receiver end. Okay, so this elaborated one I'll just draw it for your reference. Okay, so SA of t will get added with W of t, SA of t. So here you'll have x of t. X of t should get multiplied with phi 1 of t, and then integrate it from 0 to t dt. I'll get x1. Okay, next in the same way phi 2 of t, x of t should get multiplied with phi 2 of t, and then integrate it from 0 to t dt, so that I'll get x2. In the same way, okay, in the same way I'll have multiplier phi n of t, because you know that generally j will take 1, 2, so on until n. So that will be given to the product integrator, so that I'll get x n. Okay, x1, x2, so on xn. Okay, so instead of drawing this, I've just shown you with a single stage here. Okay, so where j will be equal to 1, 2, so on n. Okay, so this is how it will happen at the receiver end. Okay, so here what I need to do, I need to find xj, how xj will be. Okay, in order to find xj what I need to do, I have got x of t should get multiplied with phi j of t, so that here I'll have x of t into phi j of t, and then xj is nothing but integral of this input. Okay, so I can write xj finally as xj is equal to, first it will get multiplied with, now what is that, x of t will get multiplied with phi j of t, and then we'll integrate it from 0 to t dt. Okay, so this is your xj. Okay, converting the continuous additive white Gaussian noise signal to vector. Okay, so xj is nothing but the vector. This is how we will be representing the receiver vector. Okay, the receiver, this is what the vector we are going to get. Okay, and now we'll just further simplify it. Okay, so that xj will be equal to integral 0 to t, in place of x of t is nothing but, you know that x of t is nothing but sa of t plus w of t. Okay, so let me take that equation in place of x of t. So it is nothing but si of t plus w of t. Okay, the signal si of t is getting added with additive white Gaussian noise into phi j of t dt. Okay, let me expand this. Xj is equal to integral 0 to t s I of t phi j of t dt plus, or I'll just expand first and then write it, si of t phi j of t plus w of t into phi j of t dt. Next step, xj will be equal to integral 0 to t si of t phi j of t plus dt plus, I'm splitting the integration to this term and also to this term. So integral 0 to t w of t phi j of t dt. Okay, and if you just recall, we know that integral 0 to t si of t phi j of t dt is nothing but sij, right? You can find here sij is nothing but integral 0 to t si of t phi j of t dt. Okay, so in place of integral 0 to t si of t into phi j of t dt, I can write as sij. Okay, and this sij is a deterministic symbol, in the sense this is the one which is transmitted at the transmitter end, so this you can easily find. Okay, so sij, and this is also a constant value. Okay, plus this I'll just replace with wj. Okay, wj. Okay, so here xj is nothing but sij plus wj, and if you observe this white Gaussian noise, this is all related to the white Gaussian noise, right? Because w of t is nothing but the additive white Gaussian noise, it is getting multiplied with phi j of t, and then you are integrating. So whatever I've got here wj, it is corresponding to white Gaussian noise. Okay, so since here W of t is having mean is equal to 0 and power spectral density is equal to n naught by 2, even the Wj will also have mean is equal to 0 and power spectral density will be equal to n naught by 2. Okay, so this is a random variable. Why, how I am saying random variable? Because W of t is a noise signal. Noise signal, I really don't know how whether it is affecting the amplitude or phase or anything, I don't know. Okay, so this is a random variable. So this is Wj is also a random variable, whereas Sij is not the random variable, it is a deterministic variable. Okay, deterministic in the sense it is known to us. Okay, whereas this Wj is a random variable. So since W of t is having mu is equal to 0 and PSG is equal to n naught by 2, here Wj will also have mean is equal to 0 and power spectral density is equal to n naught by 2. Okay, so here in the exam, what they'll ask you is derive the expression for mean and variance of the correlator outputs. Correlator outputs in the sense xj. Xj is the correlator output, right? So if you just observe the receiver part, this xj is nothing but the correlator output. This is the correlator, this correlator output xj. Okay, so I need to find the mean of that. Okay, I need to find mean of xj and also variance of xj. These two I need to find. Okay, can anybody tell me what is mean and what is variance? Mean value. All of you are able to hear me, right? Can you tell me what is meant by mean value? Mean. Whatever you know, you just tell me. How do you calculate mean? Are you people able to hear me?
Yes, ma'am.
Okay, tell me what is mean?
Sum of numbers by total number of inputs.
Yeah, average. Okay, so this mean, whatever I'm speaking here, it is nothing but the mean of the random variable. Okay, random variable, I don't know what will be the random values, but it's mean. Okay, whatever mean I will be going to get, that mean I need to calculate. And what about the variance? What about the variance? Okay, so if I just want to show with one example, so this is what the Gaussian distribution function, right? So for this, how the values, the random values are spreading, okay, that will be known by using the variance. Okay, so if it is like this, the variance for this may be like 0.5. Okay, so as increase the variance, the spread will increase. Okay, the spread will increase like this. Okay, so if the spread is more, the variance will be more. That is what it means. Okay, so that parameter will be determined by the variance. Okay, see, not only for this subject, this probability and statistics is very important. I'm telling you, it is very important, irrespective of like whether you're using it or not. Make sure that you learn all the concepts. This is like, maybe I'm repeating the same thing what I'm telling you now, but really it is very important. Okay, fine. Now coming to the discussion, like in the exam they'll ask you derive the expression for mean and variance of the correlated output. Okay, so correlated output is nothing but xj. So for this xj, I need to find the mean and the variance. Okay, so how will you find? In order to find that, like we know that xj, see, we have already got xj, right? What is xj? Xj is nothing but Sij plus Wj. Okay, Sij plus Wj. Okay, first I'll calculate mean. Okay, in order to calculate mean, how will you calculate mean? Expected value. Okay, expected value of x is the first momentum. If you just recall, first momentum will give you the mean value. So expectation of xj, we can write mean as expectation of xj, which will be equal to, I'll apply expectation on both the sides. So here also expectation of Sij plus Wj. Okay, so expectation of xj can be represented as, I can split this expectation separately. I can write expectation of Sij plus expectation of Wj. Okay, so this is a deterministic signal, right? Yes or no? Xij is some constant value and it is a deterministic signal. Okay, so the expectation or the mean value of this, what is the mean value of 2? Some variable, some value I have taken. What is the mean value of this 2?
2, ma'am.
2 only, right? So in the same way, since this is a deterministic signal, the mean value of this Sij will be Sij only, plus what is the mean of Wj? What is the mean of Wj? What is the mean of Wj? Mean, generally it is denoted with mu. Mean of
0, ma'am.
Wj is 0. Okay, why it is 0? Because W of t, the white Gaussian noise mean is 0. Okay, that is the reason this WJ is calculated by using that additive white Gaussian noise only. That is the reason, since this is having a mean value as 0, even this will have mean value as 0. Okay, so expectation of WJ is nothing but 0. Okay, so from this I can say that expectation of XJ is nothing but Sij. This is Sij. J. Okay, this is nothing but the mean of Xj. Okay, so in the exam, if they ask you, you need to do this mean of Xj also. Okay, if they just ask you how I've asked in the question in your question paper, if they ask you, oh, you can just wind up here. Okay, you can just wind up here. Okay, but if they're asking you to derive the mean, you need to do this derivation as well. Okay, next I need to find how the by additive white Gaussian noise is spread. Okay, additive white Gaussian noise, since if you observe here, Xj is nothing but addition of this deterministic signal plus the random signal. Okay, so even this will become random signal now. Okay, and it will have the characteristics same as Gaussian distribution function. So for that Gaussian distribution function, Xj, you have got mean as Sij. Okay, now along with mean, you need to calculate variance also. How the Gaussian distribution, how the function is distributed. You need to find that also. Okay, in order to find that, we will take the variance. Somebody has turned on your mic. Okay, so we need to find variance also. Okay, so next derivation is I need to find variance of Xj. Okay, in order to find variance of Xj, can anybody tell me how the variance will be denoted? How the variance will be denoted? Variance symbol, there is some symbol for variance, right?
Sigma.
Sigma square, ma'am.
Sigma square, very good. Okay, sigma square, but here I have Xj also, or like I'm just giving Xj because to denote that this variance is related to Xj. Okay, so sigma square Xj will be equal to variance of Xj. Okay, I need to find variance of Xj. So variance of Xj, Xj is nothing but Sij plus Wj. Okay, so this is equal to variance. I can just write variance separately for this and separately for this. Variance of Sij plus variance of Wj. Okay, what is the variance of Sij? Can anybody tell me what will be the variance of Sij?
0.
0. Why?
It is a constant, no, ma'am.
Yeah, it's a constant. It means that it will not vary. Very good, Sujan. Plus, what is the variance of Wj? It's nothing but the power spectral density n naught by 2. Okay, so yes, sigma Xj square is nothing but n naught by 2. This is the variance of your Xj. Okay, is this clear? So when they ask you the question in that way, I'll just show you. I don't know whether I got it or not. One second. I didn't get that. I will show you. I'll open the notes, okay, which I've already shared with you. Module 2, Graham Smith. I don't know whether I have that part in this notes or not. No, I don't have that part in this notes. Okay, if you just see, maybe I have already sent it to you. It might be there in your group. Okay, so if you just see, the questions under this topic also have mentioned, right? Have you people noticed? Have you people noticed?
Yes, ma'am.
No, I will just show you. 6B. Module 2. 1 second. Let me open and show you. I just want to show how the question will be given. Okay. Now see, derive the expression for mean and variance of the correlated outputs. Okay, so that is what we have seen until now. In the same question here has also added that show that the correlated outputs are statistically independent. Okay, so this also we need to do. Okay, we have done only this part. This part also we have to do. Okay, so when they ask you in that way, you need to explain everything from here, from here till here. It is only for mean and variance related thing. Okay, then again we'll go with the second part. They'll ask you that show that the Gaussian random variables or correlated outputs are statistically independent. Okay, I'll just write it down. Show that the Gaussian random variables or correlator outputs xj where j is equal to 1, 2, so on n. Okay, that is xj and xk. Okay, where j and k are not same. Okay, it's xj and xk are mutually uncorrelated. Okay, uncorrelated when the orthonormal basis function pi j of t is used. Okay, so this is what I need to show. Okay, here what I need to show, I need to show that xj means it can be x1, x2, x3, so on like that. In the same way xk is also nothing but x1, x2, so on like that, but j should not be equal to k. Okay, so what I need to show, these two are mutually uncorrelated. What do you mean by correlated? What do you mean by correlated? Correlation. What is the use of correlation? What it will do? Correlation. See, whatever I am asking you, it is not new for you. You know this. Correlation means the similarity between the signals. Okay, that is what the correlation. Okay, mutually uncorrelated in the sense they are not same. They are not depending on, mutually uncorrelated means they are not depending on each other, or they don't have any kind of similarity. So that is what I need to show here. Okay, so I need to find covariance here. Okay, covariance is the statistical method. What it will do is it will tell how much two variables change each other. They should not be similar, right? So you may ask me, ma'am, when do we use correlation and when do you use covariance? Correlation will tell us how much both signals are correlated with each other, matching with each other. Okay, matching with each other will be measured by using correlation. How much they're uncorrelated, not matching, that parameter will be given by covariance. Okay, so here we'll try to find the covariance. Hope you people are understanding. Are you understanding?
Yes, ma'am.
Others also please respond. I'm just telling you when we use correlation and when we use convolution, covariance, and when we use correlation. Okay, so if you want to find the similarity between the signals, we'll go with the correlation. When we want to find the non-similarity will go with the covariance. Okay, so here I need to find covariance of xj and xk. Okay, so if you just recall your properties, okay, covariance can be found by taking the expectation of xj minus mean value, mean of this xj into xk minus the mean of this xk. Okay, x suffix k. Okay, this is what the formula you have. Okay, I'm not doing anything here. This is just the existing formula. Okay, this is just the existing formula to calculate covariance. I don't know how many of you know this, but this is what the formula. Okay, so if you just recall from the previous discussion, what is mu xj? I've got mu xj. We know that mu xj, mean of xj, what is that we have got?
SIJ, ma'am.
Sij. So in the same way, what will be mean of xk? Who
Yes.
is this? Somebody is calling me.
Good morning, madam.
Sir, tell me, sir.
Madam, those who have not paid the fees, you should not allow to the session, madam.
Yeah, sir. Actually, I don't have the list. I have asked the class teacher. I've messaged her. But before my class, she could not message me. So, like, I will, from next class onwards, I'll remove them, sir.
Student, it is from the higher authority which has come. We have no other option.
Yeah,
Those
yeah, yeah.
who are not paid forcefully, we have to remove them. And when you are, madam, you are making the session, no, you give us only me.
Only?
Only me, you need to change in the settings
Yeah, yeah,
in the
yeah.
lobby.
Yes, yes,
To
yes.
take the
Manage
permission here.
permission. Yeah, yeah, yeah. I'll do that. I'll do that.
Because otherwise we'll be not knowing who is joining and who is
Yes,
not
yes,
joining.
yes. Yes, yes. I'll
Students,
do that.
don't bad because I cannot I don't want to take the names and remove you people. I don't want to get into that situation. Please leave the session those who have not paid. Otherwise, we have to call your name and we will be removing your name. That should not happen. So kindly you pay your fees. So these all things will be not be present. Okay. ಮೇಡಮ್ ಇನ್ನೊಂದ್ಸತಿ ಬೇಕಾದ್ರೆ ಅವ್ರಿಗೆ ಇನ್ಫಾರ್ಮ್ ಮಾಡಿ ಹೆಸರು ಯಾರ್ದು ಅಂತ ಆಮೇಲೆ ನೆಕ್ಸ್ಟ್ ಟೈಮ್ ಇಂದ ಅಲೋ ಮಾಡಬೇಡಿ ಮೇಡಮ್.
ಸರಿ ನಾನು ಬೆಳಗ್ಗೆನೆ ಸರಳಾ ಮೇಡಮ್ಗೆ ಮೆಸೇಜ್ ಮಾಡಿದ್ದೆ, ಬಟ್ ಐ ಡಿಡ್ಂಟ್ ಗೆಟ್ ಬಿಫೋರ್ ಐ ಸ್ಟಾರ್ಟೆಡ್ ಮೈ ಕ್ಲಾಸ್, ಸೊ ಐ ಕುಡ್ ನಾಟ್ ಟೇಕ್ ದಟ್ ಆಕ್ಷನ್.
ಓಕೆ ಸರಿ ಮೇಡಮ್, ಆಯ್ತು.
ಓಕೆ.
ಓಕೆ.
So like I think all of you heard this. Okay, I know it is very difficult for your parents also to pay the fees in this pandemic, but to run the college, to pay salaries to everybody, even the management needs money, right? So it is everything interlinked. That's what I'm trying to tell you. In spite of so many difficulties, like everything is happening properly for you, and you people are not utilizing it. That is what my main concern, really. Okay, please try to understand your parents and be in their situation. Okay, as a parent, I also know how difficult it is, how like I don't want to say much. Okay, but at least when you're attending the classes, make sure that you attend properly. That is the only request from my end. And others, I'm sorry to say that from the next class onwards, will not be allowing you. Okay, this is the strict instructions given by management. Until and unless you pay the fees, you're not supposed to join the class, and you lose attendance. And again, you know the consequences of not having attendance, right? Okay, so just let me proceed with my things. Okay, so mu xj is nothing but Sij. What is mu xk? Sik. Okay, so I will substitute those values only here. Okay, so I'm not done anything. Okay, we know this. Instead of j, I have k here. So instead of j, I'm just putting k. That's it. That's all I'm doing. Okay, so covariance of xj xk is nothing but expectation of xj minus sij. Xj minus Sij. I'm just substituting these two values back into this equation. So xk minus Sik. Okay, Sik. And you also know this is what the equation we have got after substituting the mean values. Okay, and one more thing is, you know what is xj. Xj is nothing but Sij minus plus Wj. Okay, so let me take this to the other side. So xj minus Sij will be equal to what? Wj. In the same way, xk will be equal to Sik. This I'll name as equation 1, and this I'll name as equation 2, and xk can be represented as Sik plus Wk. Okay, so Wk will be equal to xk minus Sik. Okay, so this I'll name as 3. Okay, I can substitute these 3 in 1. No, these 2 in 1. Okay, 2 and 3 in 1. So here covariance of xj xk is equal to, in place of xj minus Sij, I'll substitute Wj. In place of xk minus Sik, I'll substitute Wk. Okay, Wk. Okay, so it will become expectation of Wj into Wk. Anybody have doubts until here? Anybody have doubts until here? Anybody have doubts until here?
No, ma'am.
Others also please respond. Are you all understanding? Bhavna? Kiran? Kiran?
Yes, ma'am.
Are you understanding?
Yes, ma'am.
Okay, fine. Okay, fine. So this is what Wj and Wk. But what is Wj? Wj is nothing but, you just recall, instead of some equation we have represented Wj, right? See, instead of this we have represented as Wj. So the same thing I'll write here. See, Wj is nothing but W of t convolution with multiplication with phi j of t, and it is integrated from 0 to t dt. Okay.
The group. Can you send this in the group, ma'am?
What?
Notes, ma'am.
It is there in the in that. Okay, but anyway, I'll just forward it to you. Okay, don't worry. Okay, Wj is nothing but integral 0 to t W of t into phi j of t dt. Okay, the same equation I've taken. So here, instead of what I have written Wj, the same equation I've taken. See, instead of this I've written Wj, right? So the same equation I've rewritten here. Okay, all this I'm doing only to show that the they are mutually unrelated. Okay, only to show that I'm doing all this. Okay, so Wj is equal to integral 0 to t W of t Wj of t. Okay, what will be Wk? Can anybody tell me? Wk will be equal to
Integration 0 to t.
integration 0 to t W of t phi k of t dt. Okay, so let me just substitute these two into the previous equation. So covariance of xj xk is nothing but expectation of integral 0 to t W of t phi k of t dt, phi j, first I'll write phi j only, phi j of t dt into integral 0 to t W of t phi k of t. Okay, instead of t, I'll just take some other variable, because I just want to show that those two are different. Okay, so instead of t, I'll just take some other variable. Let me take as u. Okay, and this will become du. Where is that? This will become du. Have you understood why I've taken this instead of t, I've taken u. Here also, instead of t, I've taken u. Okay, the reason behind that is this Wj and Wk are not same, right? Okay, so that's the reason I've just taken Wt here and Wu here, and pi j of t here and pi k of u here. Okay, that's all I have done here. So pi k of u du. Okay, So let me rearrange the complete equation. Okay, the complete equation can be represented as cos. I can just interchange the expectation, okay, expectation values and the integration values. Okay, so xj xk is equal to rearrange everything. So integral 0 to t, see, phi j of t and phi k of t, they are not random signals, they are deterministic signals. So I can take it out. Expectation values will just take for the random variables, right? So what I'll do, I'll take these things outside. So let me just say that this is for t, this is for u, 0 to t, phi j of t, phi j of t, and also phi k of u, expectation of w of t into w of u dt du. Okay, so hope this is clear to all of you. Until here, I have further analysis. I'll do it in the next class because it's already time up. Okay, until here is clear to all of you. Is this clear to all of you?
Yes, ma'am.
Okay, I'll just pass on the notes to you. Just go through it. If you have any doubts, you can ask me. And still, I have not finished. I didn't find the correlation value. Okay, I have to do find the further analysis. As it is time up, I'm just stopping. Okay. Is this fine?
Yes, ma'am.
Okay, okay, ma'am. Okay, you all can leave the group, and please ask your parents to pay the fees so that you'll be eligible to attend the classes and you'll be eligible to write the exam, next exam. Okay. Thank you everyone.
Thank you, ma'am.
Thank you. Thank you. మళ్ళీ ఇది కంటిన్యూస్గా